Hi everyone, welcome to the first lab of the AI 201 course, which is Introduction to Data Science. In this first lab, we cover Python basics, and also we actually assume that you already know Python, that you took a 101 course, Intro to Programming, before, either with Java or with Python, and that also you're comfortable with the basic OOP concepts like classes, functions, etc. So the first three lessons, the first three labs of this series is going to be on the basics. So the first one, this is going to be like on variables, binary operators, mutability, and like basic concepts like that. And then the second lab will cover data structures, and then the third one will be on classes and functions. All right, let's begin. So in Python, we use indentation and not braces. This can be a little difficult to get used to if you learned how to program using Java or C. But yeah, we don't have curly braces basically, and we use 4 spaces to indent our code blocks. And also, spaces are encouraged, and tab is not, according to the PEP style guide. But then, of course, like a lot of things are, a lot of things are about, the personal choice, personal preference. But there are some tricks that you can do on your IDs to make sure that when you press tab, it actually inserts 4 spaces. But then things can be different between like Py files and Python notebook files and stuff. So this is not that important, I think, in my very humble opinion, but it's good to know what the style guide encourages, I think. So, all right, let's see an example of an indentation, like where you might need an indentation. Like this is very basic, but if you want to write a control flow, like you have a variable x, and then you want to print pass if your x variable is equal to or greater than 50, and else you want to print fail, right? So you can do something like this. If x is greater than or equal to 50, so here this is my if statement. As you can see, I don't have brackets like that around my statement like I do in Java. You just write it like this without brackets, and then you put a colon, and then when I press enter, my IDE actually inserts the indentation for me. So I have a code block which is embedded under my if statement. So in this case, I'm going to print pass. So when I print enter, it's going to assume that I'm gonna continue writing in this block, but I won't. So I'll go back and say else, if it's less than 50 in this case, then print fail, right? So my indentations here actually point to my code blocks here, and also you can do like other things under print. I don't know, you can also say I don't know, print something else saying your note is, and then, well, actually it's good to also maybe talk about f strings real quick. If you remember those, maybe if you have an f string, you can do something like that. You can actually print a variable inside a string like that. So your note is, your point is, whatever that. So that will only print if you have failed, right? It won't print if you have passed because it's embedded under this code block. But if I do this, that is going to be printed no matter what. For either case, it's going to print either pass or fail first, and then it's going to print your note. All right, so code blocks are important, and sometimes because indentation can be like messy and you can't just like, in Java you can actually click. I would do that. Like you would click on the curly brace and see where like the opening brace is and see that code block like that. But you don't have that in Python, and sometimes you might be doing something wrong. Like you might have like a block messed up, which will crash your code. So it's good practice to like be careful about this as you go. And also you can actually, there are options to like reformat your code. Like here, for example, you can actually select your code and reformat your code, and then the IDE will kind of tidy up for you. Okay, so moving on from that, we use hashes for regular comments, and we use three quotation marks for docstrings. So hash comments are actually like just any type of comments. So this is very unnecessary here, but let's just say, this prints pass if note is 50 or above or something like that. I don't know. But let's say if you want to do something like this. So, okay, let's actually define a function that's called pass or fail, right? So, and then you give it a variable x. So this is my function, and what I have to do, obviously, I have to indent the entire code to make sure that this block is actually embedded inside my function. Oh, sorry. All right, so okay, so after I do this, let's just actually, okay, let's carry this here, and then let's run. Okay, we're connecting to the server. All right, so I just define my function, I ran my cell, and now I say my x is 50, so call this function for me and call it on x. So if I run this, because x is 50, it's going to say pass, and then it's going to print this. Like we said, you print this no matter what, whether you pass or fail. So if my x was, let's say, 25, it would print fail, and then it would say that my note was 25 because this is not embedded in the if block, the final print statement. So actually what I was trying to show here was, if you want to use docstrings, you need to do this. So after, for example, after you define a function, you want to make sure that you document what it does. So in that case, you need to use docstrings. So docstrings will be actually like saved with the function. So let's see that. This function prints the, I don't know. This function prints whether a student has passed or failed, something like that. Okay, so if I run this now, and if I actually come here, see, this function prints whether a student has passed or failed. Because this is a docstring, actually, what I've written here as a comment will actually be a part of my function description, basically. But the hash comments are actually ignored by the documentation. They're just there as like guidelines, and maybe for other people reading your code to make things more readable, understandable for whoever's reading your code. So most of the scalar types and also data structures are built in Python. They have their own classes, their objects, they have methods that you can, use on them. So, but there's just a slight difference between what a type is and what a data structure is, even though they're all built in. So types would be like your scalar types, like your integers, your floats, your strings and Boolean values, or the null value, etc. So these represent a single value, whereas built-in data structures are basically containers for these values, like lists, tuples, dictionaries, and sets. So also you can have, of course, abstract data structures like stacks or queues, but Python does not provide a built-in classes for these types, but you can actually import them using libraries maybe, or you can actually implement them yourself. So let's quickly see some of our variable types. So for our scalar types, like we said, we have, let's say, for example, the null value is actually written as none with a capital N in Python. So this is my null value. And then I can of course have not A, but let's say B. I can have integers like this, or I can have floats, floating point numbers with decimal points. Also, we have Boolean values. We can have true, or we can have false. So these are our Boolean values. Again, we write them with a capital T and F. So what else do we have? Of course, my integer values can be much higher. And okay, what else? Oh, also we can use scientific notation. So this number is also a floating point number, and we can actually show it like that. So that number before E multiplied with 10 raised to the power of -5, something like that, right? So this is a very small number. So you can use scientific notation like that. Okay, so actually, let's try to print the types of these variables. So for that, I have a type function. I can do that. Print type of A, right? So my A is actually a non-type, so it's a null value, so it will say class null type. Let's do the same thing for the other types. For B, this should give me an integer value. This should give me a floating point value. And D should give me a Boolean value. And E, again, should be a floating point. So if I run this, that's what I get, actually. I get an integer, float, Boolean, and a float type. So I just realized I was blocking the code, so I carried myself over on this side. All right, so that's... I quickly just showed regular division and integer division, and I showed that when you do division between two integers that don't give out, don't output another integer but a decimal point number, then my answer is actually automatically converted into a floating point number. But if I use integer division like this with 2 slashes, I get an integer as a result. So finally, we haven't seen the strings. So let's say I have a string. So basically, in Python, you can write strings in single quotes like this. You can also write them with, double quotes. I don't know I'm not sure if this is called double quotes, but like actual quotation marks. And then finally, you can do inline strings using this. So don't confuse this with your comments, right? So when you do this without any like variable here and under a function and stuff, the interpreter actually takes that as a doc string. But here, this is just a string. This indicates a string that spans over multiple lines. So you can do something like this. This string spans over multiple lines, something like that, okay? And also, after I run this line and I have set my string, I can actually do certain operations in them. I can actually count how many E's I have in a string, for example, or how many H's in a string. So we didn't get there yet, but everything is an object in Python. You probably have heard people say that before. Because everything is an object, well, strings are actually a part of a class description, so they have methods attached to them. So you can reach those methods using the dot operator. So let's reach s, my string s, and then use the dot operator. See, you just have lots of class methods here that you can apply and like use to manipulate a string. And you can check out these methods in the official documentation of Python. String manipulation is actually a very important concept, so it's good to familiarize yourself with what is available in Python. So here, for example, we can use something like this. Let's say count the E's in this string, and also let's do s2 dot operator counts. Let's count what? Let's count O's this time. Oh, like that. And if we print them, so we have 2 E's in my first string and then 2 O's in my second string. So this is useful. I mean, this can be useful in, according to what you're trying to do. Instead of iterating over everything and, counting characters one by one with a for loop, Python actually provides these types of basic operations, these functions for you. So another thing that I want to focus on for the basics is the idea of mutability. So maybe you've heard about this before. This is quite important to understand that some objects will be mutable and others won't. So when we talk about mutability, we need to ask ourselves the question, can I change this object's value after I create it without creating a brand new object? So let's say you created a string. Can you actually make operations on that string, on that object, to change it, to manipulate it? Or do you need a separate variable to reassign your new object to? So we're going to see examples of that, but basically, if you can change an object, like a list, for example, we call those mutable objects. But if you can't, like strings, for example, you can't change strings, even though you can iterate over them, make them lists, etc. You can't actually change a string that you've already defined. So here is a list of types that you can manipulate. That you can't manipulate, that are immutable. So your integers, your floats, your strings, Boolean values, tuples, these are immutable. You can't directly reach inside them and change them. If you want to change them, you just need to reassign them to the same variable after you've changed it, or assign it to a new separate variable. But these data structures, like lists, dictionaries, and sets, these are mutable. They have lots of functions which help you modify them, change them. But the issue with mutability is that it can be dangerous, because when you pass certain things, when you pass certain variables into functions, for example, you need to make sure like what operations you're doing on them, you're applying to them. Like, do you actually want to change the original list that you passed into a function? Or do you want to return a new object or whatever? Like, this is important. Like, sometimes when you are doing something else, you might end up changing a data structure that you have, which might not be what you were trying to do, and it might cause problems. But we can maybe cover this topic more in detail when we're looking at functions and how objects are modified or not inside of functions. And also we can make some like comparisons with Java, this idea of passed by value, passed by reference, and what that means. But I did not cover that in this first lab. Like I said, maybe we'll cover those when we talk about functions. So let's see a quick example of mutability. Like we said, lists are mutable. So if I have a list like this, so I define my list using square brackets, and I will, so the good thing about Python is you can actually put anything inside of a list, unlike Java, where the values in your lists, the types in your lists should match in Java. But in Python, you're actually, like, they take objects, right? And because all of these are objects in Python, they just accept everything. So here I put a string, I put an integer, and also I want to put I want to embed another list inside this main list, a list, right? So let's say I want to change the value. I want to reach let's say the second index. So this is my 0th, 1st, and 2nd element. So I want to reach this second index and say, oh, I wasn't supposed to put like maybe a list there, but I wanted to actually do a tuple, right? So, and I want to change that into a tuple. So if let's print a list here, and then let's print a list after we've changed it. So you'll see that even though the difference is actually kind of minor, this changed from square brackets to regular parentheses. So we know that this was a list first, and now this is actually a tuple. So if I do something like this, all right, let's print the type of the second index in a list. We can actually do something like that. This is like horrible because it's like I do everything on one line, but people tend to do that. So if I check the type of my second indexed element here, I get now that it's a tuple. But if I did this here, then that would actually give me a list, hopefully. Let's run that. Oh, I cut and pasted it. I need to copy and paste it. There. So first, this was a list, now it's a tuple. So we've changed it. So we can see clearly that regular lists are mutable objects. They can be modified. However, tuples are actually, like, for example, if I wanted to change this tuple, I can't, basically. Tuples and strings are not mutable, they're immutable. So let's have a tuple version where let's say I have 3, 5, and another tuple inside of it, like that. So we'll, you know, look at data structures more in detail the next class, so I don't talk too much about what like tuples are, how they work, etc. I'm just trying to show here that some objects can be changed while others cannot. So let's say that now I want to change the first index, like I want to change 5 to 76 or something. See, like it already, like the interpreter is yelling at me. It's saying, you know, you can't do that. Basically, you can't reach inside of a tuple and change a value in there. So if I actually try and run this, I get a type error saying that tuple object does not support item assignment. And you would see that if you also try to modify a string. Let's say, okay, let's try it with a new example here. Now my A is a string, this is a string. All right, like we said, I can actually reach, I'm not sure if I actually said this, but you can reach inside of a string as it was like an iterable object, like as it was a list. So if I want to reach the third index and try and print that, this will actually give me, so this is 0, 1, 2, 3. This will give me S, right? So here I have S, but let's say I don't want to just print that, but I want to change that. I want to change S to Z or something like that and say this is a string. Can I do that? No, I can't. So I get the same type of error. This is a type error, and it says string object does not support item assignment. Exactly the same error I get with tuples, and that's because both of these are immutable. So make sure that when you're working with strings and if you want to change them, make sure you reassign them after you've changed them. For example, if you had something like that, you have hello and then a bunch of empty spaces like that after hello. Okay, and then I have another string. This is the first lab, let's say. I want to concatenate my strings. So when I do that, of course, because I have these bunch of like empty spaces after hello, it's going to have them right here because it's going to be like concatenating this part directly after those empty spaces, right? So I want to do something like this. I want to say str.strip. So the strip function actually just gets rid of the empty spaces. You can see return a copy of the string with leading and trailing white space removed. So I want to remove my white space, but you know, be careful what this says. Return a copy of the string. So this actually returns something. It means that you can't just run this on the string like that. Actually, it will run, but the result that's produced here will go nowhere. It will just be lost if you don't reassign it to the same string or maybe another string, okay? You can actually do this, reassign it to the same string, or you can change it like and call this strip, you know, or like without empty spaces, whatever. Like you have to reassign this to see the effects here. So if I run this now, this should get rid of the empty spaces that we have here. Well, it got rid of all of the empty spaces, so now they are concatenated. But if I put a space here, this will work. You know, you can rearrange that as you'd like. If I have a list 1, 2, 3, And I want to append 4 to this list, like that. Oh, 4 to this list. And then if I print A, so we see that our 4 is directly appended. So I didn't have to do something like this, for example, like I did with my string. And if I actually run this, this wouldn't work. It would just like give me a none value. So you can't actually do this reassignment, like, because this basically doesn't have a return value. It doesn't return anything. Unlike the string operation, it basically just adds whatever you give it to your list. Also, with the topic of mutability, we should be careful about our references and our objects and how they actually interact. So let's say that I want to have a new reference called B, and I want that reference to point to A, point to whatever A is pointing to. So my A is now a reference, and then my list 1 to 3 is an object stored in my memory. And so I now said, okay, make B also point at what A is pointing to, right? So now if I make any changes to A or to B, the other one will also get affected. Let's see that. So if I do B dot append 4, now if I print A, not B, A, I will actually see that 4 is also appended to A, because they're basically pointing at the same object, right? So both A and B will be pointing at this object. And also, how do we make sure that they are actually the same object and not like copies of each other or something? So the way I can do that is with the ID function. So if I print the ID of the variable A or the ID of the variable B, this will give me the memory addresses and where they're stored, like the address of where they're stored in memory. So if I run this, I see that both of my variables are actually at the same address. So this means that they refer to the same object. Okay, so this works like this for lists, which are mutable objects. But if you try to do something similar with integers, for example, you see that it actually doesn't work. Sometimes this is confusing to students. Now if I make A refer to an integer, and now I make B also refer to that same integer. Okay, so let's print A and let's print B to see what they refer to. So they're referring to 5. And also let's print their IDs. Print ID of A, print ID of B. See, they're referring to the same memory address. Okay, so now if I do this, let's see, let's do it here. So now if I make my B, what did I do here? Wait, let me check. We changed B, right? We changed B and then we checked A. All right, so if I make B equal to 4 now, you know, when I ask this question, a lot of students, or like at least some students maybe, say that, oh, like A will also be changed because A and B are referring to the same object, you know, right? They're referring to the object of 5, and now I change that object of 5 to 4. So of course A should be turned into 4. That's usually how, you know, you can be reasoning, because for sure it works like that for lists. But you see that that actually doesn't work for integers because these are immutable types, and you have to think of these as like unchangeable, especially like with integers. Like I like to think of them as like they are in the memory and they're just like in their own boxes, and you can't reach inside the integer boxes to change them. You can just make references point at different boxes when it comes to integers. So what happens here is actually while your A is pointing to 5, it's still pointing to 5, your B will now be pointing to 4. So let's print A after this assignment, like that. Okay, so now my first print A statement will give me 5 right there. And my second print A statement will also give me 5 because it hasn't been modified just because B has been modified. This doesn't work like it does for lists, okay? So, but if I check B, of course, my B is now referring to 4. And whereas their memory locations, addresses, were the same before, now they're no longer the same. They refer to different parts in the memory, okay? Because one is pointing to 4 and the other one is pointing to 5. Okay, so it's good to keep in mind that, you know, like the same flow of operations won't result in the same, you know, outcomes, obviously, when you're working with different objects. So it's good to keep this in mind. This can be a little confusing, but it's good to, like, I think, experiment with this and play with it to see how different objects respond to this. All right, so one thing also I would like to mention about mutability is copying operations. So sometimes you might want to make copies of a list that you have, right? So you can easily do that using Python's, okay, let's define A again. So you can actually do something like this in Python. New list equals a dot copy, like that. So this will actually copy a, like copy that same object and, you know, put it in a different variable. So let's see how that works. So if I print new list and if I print a, I get the same result. But what's going to happen if I print their IDs? Maybe I should have just copy pasted these. Okay, so if I print their memory address, we see that they're actually different because now we've created a copy. So if I try to append something on my new list, like 4, for example, and if I print my new list and my original list, now I don't have the same problem that I ran into here, right? So because I made these two like equal the same thing, when I changed one of them, the other one automatically changed. So when you want to copy lists and you want to make them separate and do different operations on them, it's a good idea to use the copy function and not assignment like this. But there are, of course, some problems with this copy function. You know, this would work fine with lists like this. But the moment you have embedded lists, so what does that mean? Let's say that my A actually had another list inside of it, like something like that. And maybe let's say we have a list like that with nested structures, nested lists within a larger list. If I make a new copy of this using my copy function that I just used, I create something that's called a shallow copy. So now I have the original list, I have my shallow copy, so we know that these are actually pointing to different memory addresses, right? Just like we saw here. However, the issue here is this. Because we have nested structures, and because these nested lists also have memory addresses of their own, what happens when we do a shallow copy is we copy this entire structure, but we don't create new copies of these nested structures. So what's going to happen here is when I change one of these, or like when I reach inside of these nested structures in one of these, the nested structures in the other list will also be modified. So what do I mean by that? Let's go to A. So let's go to the list 4, 5 here. And then in that list, let's try to change 4, or let's try to change 5, okay? Let's try to change 5 into, I don't know, what did I do here? 98, okay. So now I changed the A list. So I changed the original list. So I'm expecting, obviously, that this list is going to be modified. So if I print A now, I'm going to see that A is of course modified. We changed the first index in the first list. So this was my first list, and this was my first index in that list. I changed that to 98. So far, so good. Normally, what I would expect is because I created a new copy here, I would expect that, you know, this shallow copy stay the same, right? This should, if I print shallow, ideally, this would still look like this. However, when I actually do print that, I see that my nested structure is also modified along with the original one. So this is definitely something that we don't want, because if we created a copy like this, we are probably wanting to treat these two lists completely separately. We don't want one to be affecting the other one. So how can we do that? If referencing, like doing B equals A, doesn't do it, if our copy function doesn't do it, what can we do? What can we use to create actual copies, actual like separate copies? The answer to that is this library called CP, not CP, copy, and we will import it as CP. Let's say that I have a new variable called deep for my deep copy, in contrast to shallow, right? So now I can do this. I can call the CP, the deep copy method, and then I'm just going to put A in there. So my A, the last time I checked, looked like this, okay? So let's actually print A, and let's print deep. You see that they're the same, and their memory addresses are also different in this case. So if I print them, so they have different memory addresses like that. So now if I wanted to change an element within the nested structures, let's change the let's do the same operation. So 98, let's go with something like that. So now if I print, so before we saw that changing the deep copy or like the shallow copy also changed the original list. Here, because we created a deep copy now, we shouldn't see that. We should actually, so A, the original list, should remain unchanged in this case, which is exactly what we find here. So our original list is this, it stays as 98, whereas our deep copy is now, 980. So now we can say that we have truly created a copy, which we can, modify without running into any issues.